Okay, now let us see how we are handling this question. It says a part of mass 2 kilograms is acted on by a force F equaling this 40, 60 squared, and then that in the case rotation. Find the acceleration of the particle, velocity after 3 seconds, then distance traveled by this. Okay. From there, it's not our force. If I write it, they are giving it now in IBM space. So this is going to be 40. This is going to be 60 squared, and this is going to be 2t. So that's my force in newtons. So the one we to get acceleration, we know that our acceleration from F equaling ma, these are now from here. My acceleration is going to be F over m. So from there, part A, our acceleration equaling to F over m, which will be our F, which is 40, 60 squared, then minus, this is minus 2t, the whole over 2. And from there, this you can write it as a half into 40, 60 squared, then minus 2t. So you can start there. My acceleration is going to be half of this is 2t, half of this is 3t squared, then half of that is negative t meters per second. Okay, so that's our acceleration. Then part B, they want us to get velocity after 3 seconds. Now, if you have acceleration and they want velocity, you know that to get velocity, you integrate acceleration. Our velocity will be equal to the integral of acceleration dt plus what's the constant of integration. So from there, my v is going to be integral my acceleration, which is 2t 3t squared, then minus t dt, then plus c. Okay, let us integrate and see. When we integrate to t, we get t squared over 2. So there it shall be a t squared. When we integrate this, we get t cubed. What we get? We add 1 divided by 3, which will cancel. Then this will get negative t squared over 2. Then plus c. Okay, so we need to get that constant. So when t is equal to 0, so when this particle has not moved, it means that now at equal to 0, from the initial position at equal to 0, you know that our velocity is also going to be 0 before it starts any moving. Okay, so this will be now 0 equaling 2, 0 squared, 0 cubed, then minus 0 squared over 2, then plus c, implying that our c is going to be 0. So here our velocity at any time is going to be t squared, t cubed, then negative t squared over 2. From there, okay, then after 3 seconds, RB into 3 will be equal to 2. This would be 3 squared, then 3 cubed, then minus 3 squared over 2. So here our velocity is going to be, this will be 9.27, then this is going to be negative 4.5 meters per second from rest. Let us add this one from rest. From rest, the velocity will be 0 at t equal to 0. Okay, so then they want us to get distance. We know that our distance is given by, so know that our part C, our distance traveled after 2 seconds. Okay, from there now, we need to get first of all the displacement. So our distance, we know it's given by magnitude of displacement. So how do you get a displacement? First of all, our displacement S is given by integrating. So our S is given by integrating V respect to T. Okay, now this will give us integral of our V. We write it as T squared, this one T squared I plus T cubed J, then minus T squared over 2K dt. Since we don't have limits, we are going to bring in a constant of integration. So this will give us T over 3 plus T power 4 over 4 minus T power 3 over 6. This is I, this is J, and this is K. Then plus the constant of integration. So this is our S at any time T. Okay. From rest, it means that it can cover 0 distance. So when S is 0, when it is 0, our S of 0 is 0. Because if you consider our body at rest. Okay, so from there, now we are going to be having 0 equaling 0 plus C. So implying our C is going to be 0. Putting it there now, our S of T will be equaling 2. Let me write it in T cubed over 3, T power 4 over 4, then T power 3 over 6. Okay, so when S is displacement after 2 seconds, so when T is equaling to 2, our S of 2 will be equaling 2. Here we are having 2 cubed over 3, then 2 power 4 over 4, then this is negative. So negative 2 power 3 over 6. So which will give us 8 over 3, 16 over 4, then 8 over 3. Reduced by 2, get negative 4 over 3. So now our distance will be modulus of S2, which will be the square root of 8 over 3 squared plus 4 squared negative 4 over 3 the whole squared. And so the answer we shall get there is going to be we shall get 4.989 meters. So that's the distance after. Because why am I taking it direct? Because initially at 0, you see that our S at 0. You can set our S when time is 0. Our displacement is going to be 0, 0, 0, 0. So meaning if I get my S after time t, still I will get this minus this, which will give me still this. So that's how that's why I just wrote this direct straight away. Because it's that to get displacement, get displacement vector, then minus this, which will give us still this. So then you substitute there and you get our answer like that. So that's it. I wish you well.